So welcome back from YouTube as well, and please open the studio, and I'm going to create what is it today? Session 7 already. File, new file, R script, and I'm going to save it as session 7. Session7.r. Now, what I want you to do, I want you to open from the materials. Can somebody post the link into the materials if someone has it handy?
I can do that.
Thank you. Introduction to R, week 5, the 5th file. And I'm going to repeat you first. I'm going to repeat you quickly. I'm going to repeat you quickly the dplyr. And actually, this is what we today want to do, because I want you to know the dplyr works. I want you to know them pretty much by heart. That this will make your all kind of work in our very way. Oh, I don't know. Can you hear me well, or is it echoing a lot? I hear a lot of echo myself.
I can hear you.
Yeah, we can hear you.
Okay, good. Then I don't worry about this. Then I'm just gonna continue. So what we looked at last time.
This guy is a Sebian.
Can you hear it all?
I will give you again the. How can I give you the rights to mute everybody?
23 participants.
23 participants.
Now let's see. Scan more and make co-host. So now Sven, you are co-host. Now you can mute.
Yeah, you are also muted because now you have to unmute yourself.
Okay. So we looked at what we looked at. We looked at dplyr, this kind of grammar of data manipulation. And this grammar of data manipulation, this had some 5-6 verbs with which you can achieve extremely much when you only know these basic verbs. And I'm going to go over these verbs one by one now. But first of all, let's see that you have PARC loaded in. PARC is read CSV, HTTP, www. You probably have it already loaded in from the last session, but I'm going to copy the link to load it in anyway into the chat. And also, is sent in the link to the materials. Please open the 5th into session 5 or something like this.
Sure.
Now, so one of the main properties of modern R is the use of piping. So the use of piping, and this was done via percent is bigger than percent via this operator. Actually, there is a native operator in R right now as well, and I think it was. I have to see, but I think it was like this. This is built into R. This second one. The first one actually comes from a library. The library is called Magritter. Doesn't matter if you load library tidyverse. If you load library tidyverse, and please load library tidyverse, then it loads automatically the library that provides this piping operator. This is R's native piping operator. It is available only for a couple of months now, or half a year now. So I am so used to the old one that I'm always open. I use this, but you can try and everything will work with this operator as well. This AND-then operator or piping operator. So what this piping operator does, it takes the result of last line and puts it into the first position into the next function on the next file. So how you usually do your analysis in R, how you usually transform data or mongo data or previous data is something like this. It looks like this, that you create some results data frame, giving it value of, and don't do it with me right now, just look at what I'm doing. You start from some initial data file, data frame, and then you do something with it. For example, filter some variable is bigger than 9, or is not available some other variable. Now notice I am using is not available and bang before it this what is it now? This is exclamation mark before it to check if something is not available. And then you do something, for example, you group by some other variable, and then you summarize and find something like I don't know, average something is mean of some variable, and you can add some other parameters to there. For example, NIRM is true or something like that. So this is your typical workflow in R. This is how I work in R. Let's say just 5-6 years ago, my workflow was very different from this. It was using mainly base R. Nowadays, everybody, all the data scientists use this modern R, and it is easy to learn, relatively easy to learn, and you can achieve things with a lot less code and with a lot less options of making mistakes in your code. Now, what were the main verbs? First of them was select, and select allowed you to select variables from the data set. So you select columns, you select data columns from the data set. Imagine that you get a really big data set with thousands of variables, but you're only gonna need some of them, some of these variables. You're only gonna need some specific variables for your analysis. Then you use select. For example, if I only want to select variables age, education, and income and write them into a new data set, I would do something like this. I would create a new data set, let's call it small PR. I am assigning the value from it, starting from PR, and then I would select. And now inside this select, you have to write which kind of variables do you want to select. So age, let's say, income, let's say, what else, education. I think there was this kind of variable. Control Enter, and now it created a new data set, small PR, which only had these three variables inside. If you look at the small PR now, then it only has 3 variables in it. It only has 3 variables in it which you selected. You can use some helper functions to select. For example, start suis or end suis, or variable 1 colon variable 2, which will have all the variables between 2 variables included in your new data set. Because usually the variables are together, which are interesting for you. So you can select starting from this variable up until this variable. You just add colon in between. For example, age until income would be like this: age colon income. All the variables between age and income would be included, and then education added as well. Or you can say, let's say what you have numeracy, literacy, let's say ends with SCI. Now it adds numeracy and literacy because both of them end with CI. Or you can find variables that contain some string or which contains, and so it provides you, it gives you a quick access to variables. If you want to exclude some variable, then you put comma minus numeracy, for example. Now the numeracy will not be included into the variables that are inside the small PR. So this was select. Now, after select is something that you use quite not so often, but sometimes it is usable. The second one was filter, and when select selects the columns in the data set, then filter selects the rows, which rows will be in the new data set and which rows will not be in the data set. it's like subsetting or filtering the data set. So for example, small PR, again, I'm writing it here, is starting from PR and then filter. And now conditions which I'm going to filter. For example, gender is equal to 2 equal signs, not 1, not 3 equal signs, male. Or if I want to have everybody whose income is not available, then is not available income. Now it's selected only men whose income is not available, is not available, whose income is some value, and it wrote it into this small PR. So if you use this small PR now, then you see that there are only men whose income there. Again, where the main these operators which to use? One is equality, is 2 equal signs. Then is not available, or negating is not available. Is this everything that you put this mark in front of? Then it negates. It takes the opposite value. Then there was this percent in percent and vector of values, which would select. For example, I could, let me write an example. Let's say I want that the person's health has to be either excellent or very good. So you see, I gave it the vector, excellent and very good, and health has to be one of these. Health variable has to be one of these, either excellent or very good. And now, if you want to enter it, you have PR, where you have this small PR data set, which only has people whose gender is male, whose income is available, and whose health is excellent and very good. How to read this is not available. Is not available. Is not available. Yeah, is not available. Yes, how do you have one question?
Yes, Sifo, please, if we go back to line number 9, the argument is our argument, or it's a built-in argument, number summarize. The average something, is it our argument, or we have to write it based on the data, the raw data? This
is how you name the new variable. You can name it however you want.
Okay, line number 21. 21, please.
Yes.
The vector excellent and very good, this is also our argument, or it's included in the raw data?
It is included in the data because I know it by heart. You usually do not know. So
yeah.
how you check unique PR.
Yeah.
Now you will see that this PR health can be either fair, good, very good, excellent, or poor. And from here you select very good and excellent.
That's right. Thank you.
And put it here. The health has to be in one of these values.
That's right. Yeah. Thank you.
I also have a question at line number 9. Can you go to line number 9? Yeah, there's 6 to 9. Here, can you explain me like what are we doing? Like first of all, we are filtering some variables, and then we are saying that do not include some other variable. So then how, if we are not including some other variable, then how we are grouping it by some other variable? Like we just excluded this. So now how are we like I do not understand this command.
So I should have written it by with normal these things, but it groups the data by some other variable, for example, gender. Let's assume this is gender here.
Okay, I got it. Like you just wrote it random variable. Got it. I thought that's a variable in the data set. So I was just confused that we just excluded some other variable in is.na, and then we are grouping it by some other variable. I got it. Sorry.
Okay, good. Now, so this filter has this percent in percent is equal to, is bigger than, is smaller than. These are all kind of logical. This percent in percent is the only one I need you to remember. from here. So let's So there is your turn at page number 2. Page number 2, there is your turn. Can you try to do this? Where you use this? Where you use all these things what we used right now. I put it all in here again, and so it is your turn at page number 2. Please try to go through it.
We are working on R5.
What?
We are working on R5, right?
You are working with PR.
Yeah,
Yeah,
I think week 5, yeah.
yeah, week 5. Yeah.
Week 5, page number 2.
Yes, five, yes, in total 5.
Everywhere I look around, love is in the air. Every sight and every sound. And I don't know if I'm being fool, don't know if I'm being wise, but it's something that I must believe in. And it's there when I look in your eyes. Love is in the air, in the whistling of the trees. Love is in the air, in the thunder of the sea. And I don't know if I'm gonna. I hear every sound. And I don't know. Don't know. Yeah, that's the way I'm looking so loud.
I made a mistake. The health is big H, not a small h, the variable name in the second one.
My result shows error because small. Yeah. Okay. Actually, I did the same as you did. I'm not sure what is managed.
The small piak, the first one was like this.
Yeah, small piak.
You
Yeah.
start from piak
I did so.
and
And
then,
select. Yeah.
and then you select these variables.
Yes.
And if you have selected them, then you can look at the, for example, here, small piak, to see the first 6 lines and the really sequence ID, age, literacy, numeracy, and problem solving skills in this new file.
Can we write like this?
Small.
Sren, no, you cannot do it like this.
Hmm.
This will not work, this touch. You have to do it the second one like I did it there. So starting from Piak and then filter, and then now is not available health, is not available study area, is not available education, or not available. You have to do it like this if you want to overwrite Piak. And but you did something wrong. You wrote a new Piak edu, which is actually a sensible thing to do. You don't want to overwrite your original data as I do here. It's considered a bad practice to overwrite your original data, but I'm overwriting the original Piak now. Frank, I need to see the code. Your whole code. It should work. Have you loaded in? Have you loaded in library tidyverse? Try to load in library tidyverse and try it again. Try and fix the solver problem.
Now we're done.
Let me copy and paste it. Your code, and let's see if it works for me. It works for me. So it's something. Run it again. Run it again. Maybe you have something open from the previous code. Because I just copied and pasted it, and it works very nicely. Charlie, you have E missing. You have %n%, but it has to be %in%. So you see the last one is here, if we can hear. So code health is starting from here, and then let's filter a bit. Let's filter so that health with big H, because R is case sensitive, has to be either excellent or very good. And then let's select only 4 variables: age, gender, health, and income. And then let's find from this good health what we created. We created the data set good health. Let's find the average income from this good health, and it is 1033.139. So exactly like I said. Okay, I will continue now. Then, if you still have questions, then write quickly. I have a question. I am in trouble right now. There are some other people who can also help you. I see that there are some very good comments every now and then from other people who are very well educated in art. At line 36, because that's it. This is the whole this code. And now I'm going to do a new something. I'm going to find mean of good health income. I could have written this as well, so that if I don't care about this writing a new file, then summarize average income is mean of income MRM is true, and now I could get the message immediately into the console.
Sipo, one question here.
Yes.
Is it necessary to run the code, for example, filter function before the select function, or does it matter?
Here it does not matter because the health is also selected. But what if I had not selected health there? Then it would have mattered, because then after selecting these variables, the next line only sees what is the result of the previous line. So here it doesn't matter, but there can be cases where it matters with what you do first.
So it's better to run the first function filter and then select.
In this case, yes.
Oh,
And here it doesn't matter. Here you can first select, then filter. But if I wouldn't have selected health, for example, then now I could not do this. If I do this, I get an error. Because you see, error, problem in filter, health not found. Because health is not found. But here I selected health as well, so it would run.
Yeah. Okay.
Okay, then there was this powerful combination of group by, and summarize. Now you remember what this did. For example, as an example, if we want to have a data frame of the average numeracy and average literacy of everybody from PIAC, we could achieve it like this, starting from PIAC and then summarize. Average numeracy is mean of numeracy. Average literacy is mean of literacy. I'm going to put them two lines so that you could see it. And this would give me average numeracy and average literacy of whole PIAC. But if I want this to be by some other variable, I want to see how it differs by gender, for example, then I would say group by gender, and then I would have this, and now I would have this average numeracy and average literacy by gender. For females, average numeracy, and for males, average numeracy and average literacy for females and for males. Or whatever else you want to put into this group by. You can put multiple variables here. For example, gender, and there was an age group or something, age 3, I think. No, there was not age 3. Let me see what variables were in PIAC names. PIAC will give me the variables. There is no age group, but let's say employment status. Employment status. And it now gives me the average numeracy and average literacy for females who are employed, for females whose employment status is not known, for females out of the labor force, for females who are unemployed, both numeracy and literacy, and the same for males. So you get this kind of summarizing tables very easily by groups without using any whole cycles or any crazy methods. This is how we rock. Now, and if you are going to use this data set later, then at the end I would add and then ungroup. But otherwise this data set would be group data and some bad things could happen with this. Now, again, there is your turn at page where I want you to do this through at page 3. Your turn at page 3, where I want you to go through this. Let me look at what I want there. Okay. So take a look if you are able to do it. It's not the easiest thing, but would be something that you would want to do at one point. Take a look and try to do it using this logic what I gave you here. Or the difference between filter and select is that filter selects rows, selects variables. So in one case, you select which variables you want. In the other case, you select which values the variables have to have. So in one case, you select whether you select gender or not. On the other case, you select that gender has to be male, gender has to be female. Actually, you know what? Struggle with this now, and I will be back in. If you are finished, then take a pause. I will be back in 10 minutes at the full hour. Okay, but try to do it now. If you have questions, still ask me. You can ask me, but I will leave you for some minutes now.
Is it a break?
It's a break, yes,
Okay, thank you.
for 10 minutes. So I will be back at full hour. Okay. And I will. What is my computer doing? So this was a harder one, I guess, and the hardest part is that I wrote it in a way that was not, you know, in this I wrote it in natural language. So let's try it. Let's see. I want average weights by education level and gender. Now let's try it. So I am starting from PIAC and then group by which variables, gender and education, and then summarize. Now inside the summarize, I need to give first, I need to give the name to the variable. So let's say this, what did I say? Call the new variable average weight. So average wage is what it is. It is mean of income, and now RM is true. Consonantal. And now you have this gender, education, average wage. If you want to arrange it as well, I add 25th and 75th percentiles. So in the same summarize code, I put comma and let's say 25th and 75th percentile. So PC 25 is, and now I'm going to use a function called quantile. Quantile needs two inputs. It first needs what variable I'm taking the quantile from variable income, and then what is the props argument. The props, it is 25, so it will give me the 25 percentile. This means that 25% earn less than this, 75% earn more than this. And let's add 75th percentile as well. Similarly, PC 75 is quantile of income, props is 0.75. And now you okay, I forgot one thing. I forgot to add NRM is true, because quantiles cannot be found with when we have missing values. So now you have not only the average wage. Averages don't show you much in many cases, but also the quantiles, also the 25th and 75th percentile. So you can see that females with basic education, while their average wage is 506 euros, the 25th percentile was 302 euros. So there are 25% in this sample earn less than 302 euros. The 7th was 545, so 25% of females with basic education earn more than 545 euros. So you can also see the distribution of the wages. That you are not talking only about the averages, but in many cases you want to show the percentiles as well, how wide the distribution is. And now if I want to arrange these results by something, and I didn't talk to you, last time I mentioned the range, but this time I forgot to go over it. Then let's arrange it by average wage, and then arrange by average wage, and now it arranges the data set so that the average wage starts from smallest to highest. So the highest average wage is for males with higher education. Now, this was quite a bit to do. Now, there was also mutate which allowed you to change to add new values or change some values in the data set. So for example, PIAC is starting from PIAC and then mutate relative wage is income divided by mean of income and RM is true. So now we created a new variable in the data set, relative wage, which is this person's income divided by the average of all incomes. So this was the mutate function. Now I will stop this dplyr right now, and what I want to tell you now is something about conflicts in packages. So and don't do it with me. Don't do it with me. You will how to say fuck up being nice. Well, work safe way. Not screw up, but what was it? I already asked it once. I always forget it. Well, you will screw up your session if you will do it with me. So what I want to show you is what happens when you have conflicts in packages. So package was, now remember, a package is just a collection of functions. In one package, there can be many functions. And sometimes the function names are exactly the same than in one package than in another package. And I already told you that that what function is used by default, it depends on which package you load by default. That's them. So take a look what I'm doing now, and I'm going to screw up my session royally, and then I'm going to show you how to get out of this situation. So for example, let me do this. Let me do this PIAC and then group by, let's say, education, and then summarize. Let's find average numeracy. Average numeracy is mean of numeracy, and now RM is true. And you see, it will give me three this nice table which says that people with basic education, the average numeracy is 246. People with higher education, the average numeracy is 290. People with secondary education, the average numeracy is 269. But let me load in one other package. Do not load it in yourself, but let me do it. So let me load in library, not the dplyr, but plyr, and console enter. And now what it says here, it actually says me that you have loaded plyr after dplyr. This is likely to cause problems. If you need functions from both plyr and dplyr, please load plyr first, then dplyr. It actually says this to me as a message, but you will ignore the messages. You have seen the messages so many times, you will ignore it. And now I'm going to run this. What plyr is, it is a previous version of dplyr. So it has a lot of functions which are the same as in dplyr, but they do not work the same way. They work a little bit differently. And now I run the very same code, this PIAC, this code. I run it. And you see, it gives me only one number. It doesn't give me three numbers anymore, but only one number. And believe me, you can go crazy with this. You can lose your hair in a situation like this, because you are going to go through your code line by line, and everything seems to be fine. Everything works. So what the hell? Why isn't it working? Because now it uses this group by and summarize. It uses it not from dplyr package, but from plyr package, from another package. It uses different functions now. And what to do? There are two options what to do now. First option that you would think that is, first option is to, before this summarize, specifically say that this summarize comes from dplyr, dplyr : summarize, dplyr : group by, and now it works. The second option is to load dplyr after plyr. But when you think that you see that I now load dplyr again after plyr, that I do library dplyr again, Control Enter, and you think that it works, then no, it does not work. It does not work like this. And why doesn't it work? Because when R is loading a library, then it doesn't actually load a library, but it checks, hey, have I loaded this library before? And it sees that, hey, yeah, I have loaded this library before, so let's do nothing. So the only way to do anything now, if you want to load this dplyr library after plyr, is to go to your packages pane. The packages pane, packages. Then search for dplyr. Where is this dplyr? It's ABCD. You see, it has this mark in front of it. Unmark it, mark it, unmark it, and mark it again. Now, why do you have to do it 2 times? It beats me. But in many cases, I have noticed 1 time is not enough. And now it unloaded dplyr and it loaded the dplyr again. And now dplyr is loaded after plyr, and now this code will work. Now this code will work and give you the right answer. So there are many cases when you have libraries that have same functions inside. There are many cases like this. In these cases, when you have libraries that have functions with same names, you write specifically the library name dplyr : summarize. Dplyr : group by. This is the way to solve this kind of problems in packages, or the conflicts in packages. So this is what I wanted to show you. Do you have any questions? I hope. I think not. I think I explained it pretty clearly. Now, yes.
What was the main difference between plyr and dplyr?
Plyr was the previous version of dplyr. So this was when Hadley first reached this logic. Then he created this plyr. Some of the function names are the same, some are different. There are actually quite big differences. So it required me to relearn it. The dplyr. I used plyr before, but dplyr is the way to go now. So, but there are some problems. Some libraries still rely on plyr. So you might, for example, there is library which you might, which is still used quite a lot. It's hmis. And when you load this library, then it automatically loads plyr, the previous version of dplyr, and then you are already screwed again. You have to now unload dplyr, load dplyr again, blah blah. So there are other libraries that still require this plyr. The plyr is actually quite old now. It is something like the dplyr is 5 years old. Plyr was the previous incarnation. So these problems are less and less. But I wanted you to see that these programs can arise, and then you need to either write this package name in front of.
So this double semicolon is right for every package?
Yes.
Oh.
Package name, double semicolon, and function name.
Yeah. Okay, thanks for your comments.
Now, conflict of packages. This was about conflict of packages. Now, what I need to show you is factor variables. And did you look at factor variables when you did the ggplot part to Zelaya or not?
No, we did not.
Okay, so what are factor variables? We have looked at character type variables. We have looked at text type variables. We have looked at numerical variables, but there is one more type of variable, and this is factor variables. And let's remind you the ggplot for a moment. We haven't looked at ggplot for some time. So a ggplot looked like this. ggplot, then data is PR, then AES, for example, X is for example education. Let's map X to education, education to X. Y is, well, let's just be education plus geom bar. And it will show us in the data how many lines there are with different education. But you see, there is basic, higher, and secondary, and this is not the right way you want to see. You want to see basic, secondary, higher. You want to change the order of this variable. And how to change it is to convert it to factor variable. And factor variable is nothing else than it is an ordered variable. So it is actually 1, 2, 3, 4, 5, 6, 7, and then every this number has a label on it. So you can order the texts as you want. Now and I want you to know three commands from how to deal with factors. First of all, if you search in the internet how to change factor levels or something like this, then you will find base R versions. How to do it in base R. Never use this. These are very, very error prone. I might show you later how you can very easily have errors with base R versions of factor variables. But I want you to use library for cats. Actually, it is part of tidyverse. So when you have loaded tidyverse, then for cats is already loaded. So see the name, play of the name, factors for cats. And for cats, it has a lot of functions that work with factors. All the functions start with FCT. So factor, then underscore, and then there are a lot of functions which work with factor variables. And I want you to know a couple of these functions. So first function is how to reorder factor levels. And this would be like this. I'm going to overwrite Yark education, saying that this is factor re-level. Factor re-level. Now it wants to know what factor, what variable is it re-leveling. And the variable would be $education. And now it wants to know the correct order of levels. So you want it to be basics and secondaries and higher. So you just write here the correct order. Basic, comma, secondary. It will automatically leave the higher, it will automatically leave it to be the third version. Okay, let me just, for the clarity's sake, let me write it out. Basic, secondary, higher. And now when you run this command, then it converts this education variable to factor variable. And this factor variable, it will be in the right order. So if you do the plot again, if I run this plot again, ggplot, then see what happens. It now shows me basic, secondary, and the higher. It shows it in the right order. Basic, secondary, and higher. It's in the right order. This is something that you're going to use very, very often when you do any kind of plotting. Because
So
otherwise, yes.
I have a question that we have to write, like if we have to change the factors, we will write this command after geom bar, like it would be the third line. Like we will write geom bar plus the PIAC education factory level.
if you are going to change it, then this should be above. Yes, if you want to run it, maybe I heard you wrongly now, but can you? So you
I'm
first
saying
need to.
that, yeah, I'm saying that we will write this after the geom bar. Like we will give this command after geom bar. Like we will add plus sign to the geom bar and then write this line to change the factors.
Well, it's important which way you run it. It can be after it, and now I run it, after. But the ggplot, if you want to run the code, then in logical order, then it should be like this. You first change the PIAC education, then you do ggplot.
Okay.
Now, then the second thing I want you to know is how to change the values of the factors. And this is, for example, what if you want to, instead of basic, secondary, and higher, you want to put on your graph basic education, secondary education, and higher education, or something like this. Then for this, you would do it like so. So PIAC education, again, I am overwriting it. I'm overwriting it using factor relabel, I think. No, not relabel. Factor recode. And now, what factor am I recoding? PIAC education. And now you need to say new name is equal to old name. So for example, instead of basic, I write basic education is equal to basic, comma, again, let's say secondary education is equal to secondary. New name is equal to old name. And when you run it, this code, then it changes the factor levels. And now you run this graph again. And you see, instead of basic, there is basic education. Instead of secondary, there is secondary education. So it changes the factor levels in the data set.
Simple question.
Yes.
Is there any function to rotate the direction of the, for
Yes.
example, basic education or secondary, something like that? Is there any function to rotate like a 90 or just vertically or horizontally? It's now horizontally positioned. If you want to change the rotation or direction of the writing.
Yes.
Under the column.
Yes. I can never do it. It's something like this. I try to do it by heart. I never do it by heart. I always check it from. Cookbook for all.
Yeah.
Charlie, I don't know what the recode function alone does. I haven't. I don't know what the recode function alone does. What different factor recode. I guess it's a basal version of the code, which is playing there. So there is team. Then axis dot text x is. No, I cannot do it. Check. You have, check it from cookbook.
Yeah, it's okay.
It's there. I always have to check it myself.
I think.
But you have to change team settings.
Okay. It's okay.
And then the third thing that you want is you want to order. Let me do a new data set. So, for example, numeracy levels by education. Let's do it with me. Starting from the arc, and I'm copying it to you in a second. Group by what are the variables in the arc? Study area, and then summarize so that for example, shall we rename the names variables? The code works with what is inside the variable, the values inside the variable. Renames the variable itself. So summarize, and let's say average numeracy is mean of numeracy, and now Rn is true. And let's write this into a data set study num. What am I doing now? Wrong. What am I? Can somebody see where is my where am I wrong now? Is it a problem that I loaded in that fucking player again? Yes, okay, now it works. So you have now the study num data set. It says what is the average numeracy by study area. And what if you want to visualize it? You want to put it on a graph. What you would do then is you would do ggplot data is study num. I promise to copy this to you as well. So let me copy this to you as well. ggplot data is study num, and inside here you would say yes, for example, x is average numeracy, y is study area plus geom column, and you will have a graph. But the problem with this graph is you see that it is ordered by study area, and it's ordered by alphabetically. But you want it to be ordered so that the highest value would be the highest and so on up until the lowest. Then what you need to do, let me just show you the graph. So you see it is ordered by randomly, not by randomly, but by this study area, but by alphabetically, A, B, C, D, F, G, blah, blah, blah. Alphabetically, but you want to order it by this value here. So one way to do is do it manually, but you do not want to do it manually. So what you would need to do is something like this. Study num study area is factor reorder. Now what factor am I reordering? Study num study area, comma, and by which factor? By the size of which, not factor, but by which variable? Study num average numeracy, Control Enter. So I am ordering these study areas by this other variable. And if you visualize this data now, if you visualize this data again, this ggplot, then you see it shows you the numeracy levels by from highest to lowest. So the highest numeracy level is for people who work in sciences, mathematics, and computing. The second is, interestingly, people who not work but studied humanities, languages, and arts. The third is for people who studied social sciences, business, and law. And the smallest it is for people who studied some service, in the areas of service. So these are the three commands that you need when you're visualizing data or doing any kind of graph, tables, or something like this that you want. You know, you want this. You want them to be in correct order. Your data. So let me see if I have some your turn so that you can try this. Try this yourself. Maybe I don't have it. Okay, actually there is your, but we already did it. We already did this, but yes, it's three things. Just to repeat them. What were they? Factor the code, then factor the level, and then factor reorder. If you know these three functions, then you can do quite a lot. But you can also check what other factor these functions are there. Factor count, factor cross, factor drop, factor expand. These are a lot of other functions which allow you to work with ordered variables. For example, factor reverses the order of factor levels. If you want it not to be in the graph from biggest to smallest, but from smallest to biggest, then you would use this factor value. Now, we have 25 more minutes. We have 25 more minutes. And I want to talk to you about one more very important thing in R. And this is a data structure called list. So we have looked at data structures like data frame and vector, but there is one more data structure. It is called list. And why you need this list is that most of the analysis that you do in R, be it regression analysis or be it whatever, it gives you back the results in a list. What is a list? List can contain any other object in R, any kind of objects. When you remember when we talked about data frames, then data frames consists of vectors, and these vectors have to be of the same length. But list can have absolutely anything inside it. For example, let me create the list. Let me first create some random objects. For example, name is Masha. Control Enter. Surname is Mishka. Control Enter, or something. You can put whatever you want there. Let's say that length is 165. Control Enter. Let's say that what else can I put in there? Well, whatever we want to put. Now there are three values, but let's say number of fingers is data frame, left is 5, right is 5, left arm and right arm. So this is a data frame now. Now, if you want to gather these all together, these values, this data, then what you would do is you would write it into a list. So I'm going to create a list. Masha data is a list, and name is name surname is surname, length is length, something, I don't know, fingers is number of fingers, constant. And now you have a list called master data. And if you look at it, then it has all this. It has name, surname, length, and fingers inside. Now, if you want to get something out of a list, then what you would do is you would also do it as almost as in data frame, master data, dollar, fingers. And you will get out this data frame. Master data, dollar, name, and you get out this master. Another way to get out something from master data is master data, and now two pairs of these, not one but two pairs of these squared brackets and fingers, and then you will get out the sorry, it has to be inside quotation marks, and you get this data frame out, what you put into there. Why do we need two brackets? Because if you would use one bracket, then you would get out a list, and not a data frame that you put in, but a small list with one data frame inside it. But you almost always want to get not the list out, but the data frame out, where you can use all the methods that can be applied to a data frame. So I want you to know about lists. When you want to get something out of lists, always use two brackets. This is what you almost always want. This gives you out the thing that is inside here. Now, why am I talking to you about lists? When you do some kind of analysis in R, for example, let's do t-test. Let's do t-test, simple t-test. Let's do it. Usually when you use t-test is when you compare two groups and you want to know if the average of these two groups is the same or not. It's not the same, but let me rephrase. When you measure some two groups, then the average of, let's say you have 10 friends, you divide them to 5 people and 5 people, your friends, and then you measure their height, and then you find the average height. It is very, very rarely that you have exactly the same height for both of their groups. The height, probably one of groups is a little bit smaller, one of group is a little bit bigger. But what t-test tells you, can this be by pure chance that one group is bigger and the other group is smaller, or is there some kind of difference between these groups? Now, we are not here to learn about t-test right now, but I hope that one. I believe you might have understood the point, but what I want to show you actually is that when I run t-test in R, when I run one sample t-test, for example, then it doesn't compare two samples, but it finds the confidence intervals for the sample. So t-test, for example, PR dollar numeracy gives me this kind of output, that one sample t-test through blah, 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 blah. Mean of X is 277. So this is what is average numeracy in PR. But 95% confidence intervals is 276 to 278. It gives you this kind of human readable output. Now, what if you want to use this output in your texts or somewhere? What if you want to write some text using or continue with this upper confidence interval and do something with it? Then one option, of course, is to copy and paste it, but this is not the R way to copy and paste it. This is definitely not the R way to copy and paste it. So you want to get it out from, let me just show you. Let me write it into the t-test into results object. I'm writing the t-test into object results. If you call out results, if you call out the results, then you see the same text again. But if you look at what this result is, and you use this function str is structure of the results, then it shows you that it is a list of 10, and it has these kind of variables: statistics, parameter, p-value, confidence, estimate, null value, and so on. So for example, if I want to get this confidence intervals out from there, then I would say results $confidence, and it will give me confidence intervals with two values, with attributes, some attributes as well, but forget about attributes. If you want to get the first confidence interval from these two values, the lower confidence interval, then you remember how to go inside the vector. You go inside the vector like this, that you do it like this, like me. So found one and console enter, and it shows you the first confidence interval, the lower confidence interval. The higher confidence interval would be vector the second value, and it's 278, 276, 278. So this is how you get inside the results object. And this is something that you use really often when you run a regression, when you run whatever kind of analysis in R, then it always gives you back a list of all the parameters, of all the results and so on. So to get the specific values that you are interested in out from the list, you do it like this, that you write it first into the data object, and then from the data objects you find this confidence interval. What is inside this data object is a vector called confidence interval. Inside this vector first value, inside this vector second value. Oh, these are lists in R, and you really are gonna work quite a lot with lists in your work. Now, some peculiarities about lists, some funny things about lists. For example, what we'll think, I'm going to create a list 2, and I'm going to say that it is a list, and I'm going to put A is 3, B is 4, or 4, and again, I'm going to make a mistake. I'm going to write A again into here. A is 5. So what do you think? What is list $2A? It is 3. It doesn't say you, it doesn't warn you, hey, you have by accident written 2 A's into the list. It doesn't say anything. The only way to get the third element of the list out is to write list 2, 3. Third element of list, it's 5. So in data frame, you cannot have variables that have the same names. In list, you can have variables that have the same names, and it just shows you the first variable that it found inside the list if you call it out. Be careful with this. Doesn't even warn you that there are 2 ways. No. Okay, now I have told you about lists as well. We have 15 more minutes. What do you think? Should we go over functions, or should we leave functions a little bit more time, and should we end it today?
I think so. We can start the new topic next time. We can leave today. Like we can start the new topic next time because it's already 15 minutes left.
Then let's continue next time. But when will we do the next time?
So tomorrow you're not available.
No, I'm not available. Yes.
Yeah. So when are you available next?
I would be available on Friday, but I understand that on Friday there is, and I will ask from you actually. Let me